Okay, I think we're getting a good number of you starting to join, so we will get started. We've got a lot to cover today. So welcome to the Helix webinar session. Today's session is going to be on Helix Discovery. We're going to be covering CMDB Sync Customizations. I'm joined by Matt Lammy, our product manager. He will do his formal introduction shortly, but before we get started, just a reminder, there is the Q&A section of Zoom at the bottom. If you do have any questions during the presentation and demo, please put your questions there. We have a lot of time at the end to go through to the live Q&A as well. So Matt, I'm now going to hand over to you to get us started.
Thank you, Sam. Hello, everybody. First of all, apologies for the reflection. The only light in the UK today appears to be my monitor screen. So apologies for the light and dark shadow. So yes, hello. Today we're going to take a bit of a look at CMDB Sync and the customizations. And I feel that to a lot of customers, they're a bit of an unknown quantity or a dark art. And we want to try and draw back the curtain a little bit. So let's have a bit of a conversation. So we're going to talk about what the opportunities are, how we may approach those solutions, and then we're actually going to look at the value and look at doing some walkthroughs on how to manipulate some data going into our CMDB. So today we have the common data model in CMDB, best practice common data model for CMDB. A lot of people who may have the CMDB background will recognize that shot in the bottom left corner. We have an awful lot of available places to put data, and we put an awful lot of data over. I think we're over 170 sync mapping patterns today, covering everything from the devices to certificates to business services, all with the idea of sending the minimal set of data for your business outcomes, things like change management, risk management, full up the ITSM, the service management. And the primary use case for Discovery is not to copy itself to the CMDB, but to send over what is required for an outcome, whether that be asset management and serial numbers and makes and models, or whether that be business services and all of their content, pushing over what's required to fulfill a good ITSM service. And I've put a quote on the challenge page that we have today. This is a quote direct from our documentation, the BMC documentation, and I believe Sam's going to send the slides out, so please feel free to click all these links at your own time. But we have a comprehensive mapping solution today to push exactly as I've mentioned, the relevant amount of data to fulfill your outcomes. But there may be times when you have requirements beyond those best practices. Some examples we're going to use today are: you may wish to reformat your data, you may wish to standardize a value in a field. CI name is quite a regular one on computer system, and we're going to look at that. There may be times when you're looking to use the CMDB for more than the best practices, to do more with your CMDB, and Discovery has some data that can help fulfill that. And an example we're going to look at is to send over some file system information. It's data that exists in Discovery. There is an out-of-the-box CI in the CMDB, so we're going to just walk through pushing that data over. So, as I say, there are opportunities to map data to fulfill your challenges. Out of the box, we have 170 odd patterns. We have some templates. We have some demonstrative templates where you can go into the UI, you can look at those examples, and you can springboard from those templates to whatever your requirements may be. We're actually going to use one of the templates and the examples that we're going to work through to demonstrate how there can be multiple ways of achieving your outcome, whether that be using an extension or a full override of the out-of-the-box patterns. We're going to work through those. So, as I've mentioned, some of these examples we're working through. We're going to look at the templates that are. You can all go straight into your Discovery UIs right now, and you can grab those templates, have a look at them, see how they're working, see if any of them fulfill your requirement right here, right now, to really be able to make the best out of Discovery. Then we're going to look at some examples, and some of these examples have actually come in from the communities over time. And I just want to say thank you to Michael. He's an attendee on the call today. He contacted us after one of the previous sessions and highlighted that there were some communities posts, there were some questions, and there are others on there. So we've actually been able to hopefully deliver on Michael's examples to help with his particular example. But it's a demonstration of a use case. We don't want to just blindly send everything to the CMDB. We want to have a purpose. And with that purpose comes a requirement and a definition, and then something that we can stand behind. Otherwise, we're just sending data for data's sake, and there's no consumption. So with that, I'm going to switch onto demo mode. So we're actually going to go into Discovery. We're going to open up some patterns in VS Code and work through them. And then we're going to look at that data as it's gone over to the CMDB. And so we'll do a quick view of the data in the ADDM import dataset and in asset, because there's no reconciliation set up on that environment at the moment, to see the change in the data. So I'm going to stop sharing my.
Okay, and this good.
This is the point at which I actually check. Can everyone see Discovery right now?
Yes, it's on there. Yeah.
Thank you, Sam. Thank you. So to those who may not be aware, this is BMC Discovery, and BMC Discovery has a wealth of data based on API scans, IP scans. You go out, you get all of this data. And all of that data can be quite overwhelming at first. And then we try to say, well, some of that data goes to the CMDB. And it can be quite daunting to know what data goes over, what data doesn't go over. It looks like this in Discovery, but it looks like that when it gets to the CMDB. So we have this idea of transformation. And we use sync mapping patterns to transform Discovery data and relationships to classes and fields in the CMDB aligned to the best practices coming from the CMDB. So if the CMDB, if a new capability comes out in the world, the next cloud thing, the next containers thing, when that becomes something that we can discover in the tool, the CMDB will define a set of attributes and relationships and classes that we can push that data to. And that will come out in TKU content as the world evolves. Cloud was an evolution. Containers were an evolution. Data always gets updated in the world we work in. So where do these patterns exist? In Discovery, there is the concept of, we call it the TKU, the knowledge update, a set of patterns that trigger on things and do things, whether that be trigger on a discovery, a piece of information from a discovery run, or whether that be transform data to look like CMDB data. And with that CMDB data, I'm going to zoom in a bit because I'm assuming it's a little bit smaller on screen. Is that a bit easier to read, Sam?
Yeah, maybe a little bit more for others. My eyes are pretty good, but not everyone's maybe perfect.
I'm getting to the point where I'm avoiding glasses, so I'll go with that. So we have this TKU, and the one we're looking for is the default TKU, the thing that on SaaS is just there and updated every month. If you're an on-premise customer, you can download the files every month and update and benefit from the work that our content team are working on tirelessly to extend, to grow what we discover, map into the CMDB. And there is a section under this TKU. If I click on the 1725, there is a section called Operation, Discovery Operation. And there's a section CMDB Sync. And here are the folders and the mappings and all the good stuff. Now, for the sake of argument, today we're going to focus primarily on the traditional servers, networks, data that looks to go to computer system and clusters and fairly traditional mapping data. There are cloud mappings, and please, any questions, have a look. If there's opportunities for a further conversation around the cloud mappings, we'll do that. We're not looking into those mappings today. Equally not mainframe or storage. We're focusing primarily on host-based mappings. And in here, you have the mapping files themselves. There you have the naming convention is discovery node type to CMDB class. So if I go to host, we can actually see that we split a discovery host node into 3 different CIs. We do the computer system, make, model, serial number. We do managed controller. That's your hardware interfaces, your ILOs, your iDRACs and stuff like that. And we create the operating system CI. So we actually map one piece of data to, well, 2 pieces of data to 3 different CIs in classes in the CMDB. And there's over 170, as I think I've mentioned a couple of times. So there's quite a lot in there. That's what Discovery does out of the box. And that's always a good starting point for any new requirements you have. Where is it doing it? And where might I want to change? And that then leads you to the conversation that we'll talk about later of, do we want to extend or do we want to override? Or is there something missing in there that we need and we need to add and create something new? So this is all out of the box data, what Discovery does to underpin your CMDB with as much data as is required without going the extra step of flooding your CMDB pointlessly. I mentioned earlier that we have templates, and it can be a little bit quiet and unsung. When you go to this knowledge page, there is an option in the top for creating patterns. And if we click on that, we're going to go into the templates. And within these templates, I've never really counted them, but it looks about 20, 30 to me. There are some examples to help you get started. And there is sometimes opportunity in those templates to go, well, I need to do something, I know how to do it, but I need to do something slightly different. Always worth having a look at the templates to see if there's something in there. And if I scroll down, we will see some start to emerge with template CMDB. And I'm not going to walk through all of them. We're going to look at this one here, the host name change. And the reason we're going to look at that is that we're then going to use that as an example of a compare and contrast and most suitable place for you to do your changes. So we're not going to download it. We're going to click on it and it will just open it in the UI for us. And at this point, we're starting to talk TIPL. So we're starting to look at the code and the TIPL writing and how a sync mapping works. So you within a TPL pattern, you have broadly 2 concepts. You have a standard pattern, go off, do something, manipulate data that may be discovered, DDD data, directly discovered data, or it may be inferred data, managing the data within Discovery itself. You then have this secondary type of pattern, the sync mapping type, where you're transforming the data specifically to push out from Discovery to a CMDB. And just to call out, we are talking primarily today to Helix CMDB sync mappings. The same principle applies to the ServiceNow mappings that we have available in Discovery as well. So in this module here, this is what's called an extension module. This is going to take existing mappings, the out-the-box mappings for the host computer system, and it's going to remanipulate the data. It's going to take the name from the out-of-the-box computer system mapping, and then it's going to change the host name to a short name. which is what this line here is saying. It's basically going to drop the FQDN. Excuse me one moment. It's a bit too early in the morning. So this data here. So we have standard tipple, version, name. We have imports. So with the patterns, there is the concept of overrides and extensions. And if we're looking to override or extend an existing pattern, we need to import it first. So we're going to import all of the results from the out of the box pattern, including category type, lookup tables, all of this wonderful stuff. We're going to import that pattern, which effectively imports the results from those executions of those source patterns, and we're going to manipulate. So we're importing from the root node host computer system, import the host computer system sync mapping pattern within the out of the box. And we then have the mappings section. So we have a sync mapping name, we give it a name and a version, standard tipple there. The overview does not say anything a lot about overrides, and we will talk to that later. It does say extension as a tag, just a bit of a nod to say we're extending another pattern. Mappings from, and then this is very flat right now. We're literally going into the imported data. So the import the host computer system pattern, and we're saying grab.host, which is the node. When I say node, I'm referencing discovery nodes, not CMDB CIs. So we're saying go to the imported pattern, grab the host, import it as host. And that's it. We're just importing all the host nodes that are being triggered by the source pattern. We then go into the body, and the body is where we start to do stuff. And in here, we want to initially we've pulled in the hosts. We now want to pull in the created CIs from those original patterns. And so we've got the computer system here, and we go back to the original pattern, host computer system, but we're pulling in a different thing now, and we're actually pulling in computer system. And this is where it can, when we're starting to do sync mapping patterns, and I've been guilty myself, you get those two the wrong way around. You import the results, the computer system, you actually import the results, the CIs, and you would then look up the nodes, and nothing works, and it doesn't make sense. So I would always recommend paying attention to what is in your source, and it's not always going to be .host. It's not always going to be something that makes sense to us all. It may well be that map created .xyz and .123. So always pay attention to what we're importing and what we're mapping. So with these two sections, the mapping from and the computer system, we have the imported nodes and we have the resulting CIs that came from those core patterns. And so we can start to manipulate the data now. So we have hostname equals CI dot value dot at field, and the capitalization tends to be the giveaway. That's CMDB uses capitalized and we use lowercase, so it sort of helps us a little bit. So we're grabbing the host name, and then we're looking to see if it has a dot in it. Is it a fully qualified name? If it is, then rename or reset that value to a text split of the host name, splitting on the dot, get the first bit, get the short name. So we're actually resetting this value in this line here. We're resetting to grab the first part. And then if we've done manipulations, then while we're at it, we're going to update the token ID so that we can maintain some consistency in the data going across to the CMDB. Now, this is an example, very simple, very just two changes. But ultimately, we're looking to do one change. We're looking to take any fully qualified names that we're pushing across to the CMDB and convert them to short names. And that can be a requirement, a legitimate requirement, because With things like a Linux server, they will always be fully qualified. That gets pushed over to the CMDB, and when you're trying to run reports, that column of host names becomes quite messy and difficult to read, especially when you're talking to non-technical consumers of your reports. It's a prettying effect on your outcome. So I know we spent a little bit more time than I would have liked on there, but it was to try and work through what we are doing, because that is the basis to everything else we're going to talk about, and I will not be digging as hard into the points that we've gone through here. So hopefully we can now go back. So to all of you, please go through, have a look, see what the templates do, see if there may be questions that they trigger, or if they deliver on questions that you already have. So let's go back. And I don't know why that keeps showing up. So there are out-of-the-box patterns. There are templates to allow you to make a start. And the point of today is to run through some examples and to actually look at some patterns that we have, some opportunities, some questions, some communities, ideas that have come in. And so we're going to look, just because of alphabetized, these are all pretty much out of order. We're going to look at overrides. And then we're going to look at extending, which is more like the template we've just looked at. And then we're going to look at mapping some new data. So I can never remember the order that I did this in. CI name. So today, this is a compare and contrast to the code that we've just looked at in the template, where it's importing the results. So the out-of-the-box pattern has set a name attribute. The template will then ingest that, and before it pushes the data to the CMDB, it runs its own job and changes that name field to a different value. We're going to approach it slightly differently in this example. And this is why we're starting with this, is to show that we're going to do the same thing. We're going to create the same result, but the pattern's going to be much longer. It will require a certain amount more management over time as TKU content, bug fixes, new opportunities in the CMDB come up. It will need a certain amount more management by using this, but we're actually going to do two things here. We're going to rename, and then we're going to set to uppercase. But it's the same concept. Short name is what we're looking to push to the CMDB. So when you import an override, when you create an override, there are some additional pieces of information you need to put into your pattern. So in the example, we had the original import from host computer system, bring in that data. It's the same concept with an override. In this example, we're actually going to do all of the mappings, the sort of root node mapping. So we're going to apply this to the hosts, the networks, the printers, the storage, the SNMP devices, everything that's already pushing data. You can do it all in one pattern, whether that be an extension or an override, you can do it all in one pattern. So we're going to ingest all of those potential places of creating a computer system. There are more. There are always more. This is not an exclusive list. It never is. It's just an example of how you can apply one pattern to multiple pieces of data. As long as the structure and the processing is common, then you can apply the same single outcome. When you do an override, you're effectively having to repeat the entire pattern. So if you look at the source pattern, it will have lots of tables, it will have multiple tables, it will have lookups, it will do everything that the pattern is doing. That is basically the source code. And if you want to have an override, you then become responsible for keeping an eye out if there's a bug, or if the vendor has provided an update, or if lists have changed. You are now responsible for doing that. And that can be a deciding point between using an extension and basically double processing, or completely overriding the pattern and saying, great, thank you, Mr. TKU. That's great. I don't want to have to update it every single month that there's a new update on the or a new TKU comes out. So I'll create an override that whatever is in the TKU, I will look to override. There's an additional section under overview, and that is data model is in most code. I know it wasn't in the template, but it's in most code. Data model just says to older versions, when we're looking back to, if for anyone who's using on-premise Remedy, ITSM, or older versions of the data models, I haven't seen anyone using those older models in a very long time, but we have the ability to pick and choose data models, and we can actually send different data or create CIs with different fields against different data models. The one we want today is overrides. So I'm going to call that name out. And in this pattern, even though we've imported all the other data, the one ultimately that these all point to is, oh, no idea. Oh, was that bit of AI showing up? All of those printers, network storage, they all ultimately relate to host computer system. So we're going to say this is the pattern that we're going to override. And that tag of overrides is very specific to that. What you've imported, we're now saying this piece of code overrides it. So if I took the body and deleted everything, we are overriding to say, ultimately overriding to say, don't do anything. Just create a log entry. Don't do anything that's in that pattern if we have an empty body. We are overriding the entire content of that sync mapping section. To call out, when we have imported that, we have not imported this enumeration, this table, this table. We have only imported the sync mapping section. You can import the tables. You could import the tables from from other patterns to reduce the number of rows in your patterns, or that allow the vendor to manage the tables, and then you manipulate the sync mapping pattern. So we have imported host computer system. In our tags, we are saying override that original source. And then we are leaving everything else in the pattern today the same. We are doing two changes, and that is to change to a short name and set the value to uppercase. And I'm going to scroll through, and we're going to find somewhere around here a demo reference. Plugging into this pattern, it sets a value here, which is getting the value of the FQDN or the host name or whatever it is. And so we're going to, and apologies for the indentation. If you remember in that template, we're doing the same thing. If it has if a value has a substring of a dot, then it's probably an FQDN. So set that value, override the value with a text split to grab the first part before the first dot. So grab the short name. And then I'll put up an SSH session in a minute, and we'll do a run of this, and we'll see that value being updated so that everything should show as short name. That's it. That's all we're doing for manipulating the data until we push to the name field. So this section here is where we start to create CIs, or sorry, create data in Discovery to look like a CI that then gets pushed over to the data set. And if you notice here, we have data model 2, 3, 4, 5, 6. We don't have 0 and 1. And this is primarily, it goes back to older versions of CMDB or Helix CMDB or Remedy CMDB. They may not have had all the fields that we want to push to. As the world evolves, we get new attributes. So 0 and 1 obviously didn't have all of these attributes available to them. So 0 and 1 we actually split out and do separately. We were only going to focus on the first one because that's the only one that we really care about. Anything that has 6 in it, current, we're going to be good to go. So in here we are creating a computer system. Now to call back to the original template, this first line of the body was computer system equals host computer system dot computer system. This is where it's pulling from. This bit here, we are saying computer system, all lowercase, is the CI that is created. And we've got a sync, create the data with this class, with these attributes and these references. So the host keys, this is where we set text.upper. So we take whatever we set CDM to up the top, which was short name, and then we are setting it to uppercase. We could have done this up the top. We could do this here, there, or anywhere. It's an example of how we can do the same thing in different places at different stages in your code that may achieve different outcomes for you based on whether you expect the data to always be available or not, or always ready to change at a certain point to create other variables that you want to consume. In this example, I always expect it to have a name, so I'm rather confident that if we are trying to create a CI, we have already weeded out anything that doesn't have a name, so set it to text.upper. Nothing else I want in this data needs to be uppercase, so I've set it there. And that's it. What we've done is, in the template, you have imported all of this code and you have edited that CDM name value on the fly. You've taken the outcome of this, imported it, edited it, updated it before it is pushed to the CMDB. So you've allowed the original patterns to do their work, and then you have secondary manipulation on the data. In an override pattern, you are doing that data at source. You have to import all of the code, make the edits that you may or may not want, and then you upload the code and it will always override. So everything has a consideration when you're looking at creating sync mappings as, do we need to take on the management of that code? Is there so much change we want to make that it's better to do it in override? Or is it okay that all we're doing is changing the format of the host name? Let's do that in an extension pattern. So allow the TKU to run, extend, change that bit of data, let it go to the CMDB. So that's an example of pushing data, of changing the host name. And I'm going to go into Discovery, and we're going to just kick off a sync. And please, let's have a look. We're going to synchronize all the data to the CMDB. And then, because it's very small, hopefully by now we will be able to go into our CMDB. To anyone who hasn't seen it, this is the CMDB dashboard console. Some of you may be used to the blue forms, the back end forms. I'm using the front end today, but the outcome is the same. It's just that it's going to be slightly more clicky button than typing in. So we're just saying, go to the import data set, get all the computer systems, and we should see a result appear at the top. And with a bit of luck, we will only see short names, and we will say a mix of uppercase and lowercase, and that was by design. Anything that I know is a server. So we have these three are servers. They come in, they are host nodes. The rest of them are printers or network devices and storage. And this is where I want to call out that we need to pay attention to, whilst we've imported lots of data, we might not always apply it to everything correctly. And this would be an example of where an extension would be easier. So we have changed, we overrode the host computer system pattern. And therefore, when that is pushed to the CMDB, it has cut off the short name, it has set it to uppercase, and it has pushed it to the import data set. If I was to look at one of these let's look at this one with a bit of luck. And if we show CI details with a bit of luck, it's never in alphabetical order. With a bit of luck, if we go to the name field, yes, so name field, this is what's in the import data set, our manipulated data. And because reconciliation hasn't run, it hasn't pushed through to asset yet. So originally, this is what Discovery pushed. We wanted to drop the FQDN. We wanted to make it all uppercase and look pretty. We have achieved that. So in a nutshell, we've achieved, but we haven't. We haven't actually applied that to network storage printers, SNMP devices. We would need to basically copy and paste that pattern now. And where we have all of the imports at the top, copy and paste that pattern with an override of the other patterns that we want to apply to. So where we had host computer system, we need to do the same for network device, computer system, printer, SNMP, and storage. We would need to copy this pattern leave the tables, but copy this pattern in a row to apply to all of the node types that we want to manipulate the data on. This is where the extension pattern would be a better option, because if we're having to create so many patterns, there's an awful lot of manipulation going on here. And when we looked at that template, it was just a couple of lines. So I would recommend in this example, lots of copies of the pattern to apply to all of the node types that you want going into computer system, but use an extension. So just allow that double processing to occur, because you don't need to manage this anymore. You can do it all, take the data, let it create once before it goes to the CMDB, make your edits, push the data. And that would then apply to printer storage networks. So that's example one. I will try not to take up too much time on the rest. There was a question that came in, and again, thank you, Michael, for this one, because it really caught me off guard, is how do we change system type? It's a field on computer system that is a list entry in the CMDB, and how do I change it? And to most people who look at a computer system, if I look at one here, let's go down again. If I go to hopefully S, and it should already be set as I want it to be. Yes. So system type. So system type out of the box was coming through as x86 based PC. How do I change that? I want to create some custom system types in my CMDB. I want to extend to the bleeding edge technologies. Whatever the reason is, how do I extend that data? And you think, because it's coming in on the computer system CI, you think, oh, I'll go and have a look at the computer system sync mapping. And let's do that. Let's have a look at the host computer system sync mapping. And to save a bit of time, I'm going to just do a word search for it. And we found 3 entries: virtual system type, virtual system type, virtual system type. We have not found the attribute that is being set by Discovery. Where is it? Where is it being set? And that can be confusing, because the way sync mappings or patterns in general work is they can be layered up. You can create a piece of data, whether that's inference data or a sync mapping pattern, and you can create a secondary pattern that triggers off that and extends it and goes down and down and down. And the example that we're going to end up today is processors, CPUs, processors. They are an extension to computer system, and they actually backfill that attribute onto the CMDB, onto the computer system CI, sorry. And so it can be a bit interesting trying to figure out where did that attribute get set by Discovery. And sometimes the brute force approach works. You type it in and hope that your capitalization works, and you look for patterns. We got very lucky here. Now, ignoring this one, this is the one that we're going to look at. There is only one there that says CMDB. There is only one there that says host. and there is only one there that looks, so therefore there is only one there that looks like it might have that attribute in it. My mouse has decided to get stuck. There you go. So we could look at these two. We're not talking about superdomes and we're not talking about flash storage. We know we're talking about posts and we know we're talking about CMDB sync mapping. So we're going to jump in there and we're going to have a look. And we're going to just do another word search, 7 entries, looking better. And we're hoping to get the capitalization correct. So there's an enumeration talking about it. There's a comment talking about it. And there's some stuff talking about setting it. And if we keep going down, there is a piece of code that seems to be saying computer system. I recognize that. That comes in. That's what the sync mapping calls it in the default root node of computer system, and that's the attribute I'm looking for. So by doing a brute force search, we have found a pattern that appears to be setting that value. At which point I'd be going, there's a high chance that's the one I want to look at. And I would then look at this pattern and go, how is it working? What is it doing? Oh, it's creating processor nodes. And if I look down, it's creating processor nodes and it's creating relationships to computer system. It's doing all of this funky stuff for these classes I don't care about, but part of its job is to set that attribute. So I would then download this pattern. So we found that we know computer system is being created via a core pattern, a top level pattern. We know that it is it depends on the computer system pattern. Again, that comes from these imports here, the host container, and it's depending upon computer system here. And we know that it's setting the value. So it's more than likely the right pattern to look at to get the data we want to manipulate. And I would download the pattern, edit the pattern, and I would then set it how I want. And just so you're to call out something here, pattern modules depending upon this. So that is our override pattern that is actually importing from this pattern to do what it wants to do. So you would download the pattern, make the changes you want, set it as an override pattern or an extension pattern or whatever however you have chosen and seem most appropriate, and then upload it, and you will end up with the override. And this one is created by me. We do all the same imports. We are actually overriding. Again, we are looking to manipulate, to do an override of whatever this pattern's doing. The reason for that is that I want to override the entire thing. I want to set my own tables. So in my CMDB, I created an additional entry for system type of testing, item number 11. So I extended the list, I extended the CMDB. And in here, we went through, and because there were multiple places that this data was being set and consumed, I felt it was better to override the pattern rather than try to manage all of this capability that it's creating the processor class, editing, trying to override and slide that override in at the that extension in at the right place at the right time. It would have been unwieldy to approach it that way. So we literally just go in and we ingest the entire pattern and we make those little changes that we want and we set them. And in this example here, it is literally just reference our new entry in the table up the top. And that's it. That is the only change that we needed to make. And that means that when this then pushes that data, it is going to push the example we want. So we have changes to our CMDB, we have updates to our enumeration tables in the code, we have a simple change in the code, but the outcome or the idea turned into a full override with the entire pattern rather than just the extension pattern of very short, very sweet, very efficient. And just to go back to the CMDB, the resulting is we did a sync, and because all these patterns are already there, a lot of this data is already here. So testing, we are pushing that data over. There was another question, and I'm going to skip a couple of examples and go to our extension patterns. And even though we have already talked about using an extension pattern to manipulate data, we could equally use an extension pattern to just add some new fields. If someone in our CMDB has come to us, we have a new field, or we want to populate an existing field that you don't map to, we can do that. And this is where it becomes really good and really exciting to do really quickly, really efficiently, is an extension pattern to just add a new attribute of value. And so my SACM team, they came to me, they said, we want to know the source. We have this attribute called source in the CMDB. We want you to populate it with yourself, with a string, BMC Discovery. So back to the pattern, we ingest from everything, we give it a random name. We don't need to, all we're doing is referencing the outcome of, the nodes and the CIs from the original patterns. And where on the last example, we only imported from host computer system, you can do them all at once. And this one here is doing just that. It's importing all of those node types, all of those nodes lists, sorry, as a single variable name device. And then we are mapping any of the CI creations. And because we'll be triggering on a network device, a host device, these two will always be joined. You will always be mapping from a host computer system host. You will always be getting the host computer system CI. We can ingest all of those in one place. So for any network device, any storage device, any network storage host, any of those mappings that we put to computer system, they will achieve they will be mapped to a mapping of computer system, and we just say set the source field to this. That's it. It's an example of how we can do many things in one. And I know previously I said we need to create multiple patterns. Again, there are two ways of achieving the same outcome. You could have different patterns. You may want to say, well, for networks, I want to do it this way, and for servers, I want to do it this way. Or you may say, no, for my reporting, I want one single outcome, and you can manage it all in one pattern with just a couple of lines. And because we're getting a little bit close to time, I'm going to talk about extra data, new CIs that we have never sent to this class before. We want to push it, but it still has a relationship back to the computer system. So for all servers, we want to send the local file systems to the CMDB. I wouldn't necessarily recommend it, but it's an example where you may be doing something with your file systems for charging, I don't know. So we are saying from the host computer system, so that has all of the existing data, make, model, serial number, operating system relationships, all of the existing stuff, grab it. We want to add to that list. Any data model, we could have limited that to just 6 in this instance, but I always just send to all of them. Our mapping, and this is where we look at traversals. So as we have in query language, we can traverse from one thing to another. So in this example, we're saying go to the imported mapping for host, grab all the host nodes as the host, but now I want you to traverse from those hosts down to the mounted file systems. So we're digging into discovery data into a specific area of extra data, and we're going to consume those FS mounts, as we have called them. And we need to declare the class that we're going to be calling, and we need to declare we're going to create a F system entity, and we want you to map it to the file system class, and that matches this piece here. So pay attention to capitalization and spelling. I've made far too many spelling mistakes between that bit, and that shouldn't actually work, because the example I've just given shouldn't has that spelling mistake. I've said file system here. I haven't said I've said local file system here. So that's a purposeful mistake to show how easy it is to think, oh yeah, it's this class. Pay attention to that bit and that bit, because there is no data in my CMDB right now because this doesn't work. So we are going from the host nodes, imported host nodes lists, down to the file system, and we're going to create a file system node, but we're not actually, because I've used the wrong class name. As before, we are only looking at host nodes here. Computer system, reference the imported pattern and grab the created CI. And then for every file system mount that we find, if it's a local, so I don't want to do remote file systems, you could double this section and say if local, then create a local file system. And I believe there's a remote file system CI class in the CMDB. This is just to show the concept. If it's a local, create a file system node with these attributes and create the relationship back to the computer system. And this is where you may say, I don't want a dependency relationship. I want to use a different relationship type. And that's it. And that, but for the mistake, that is all you need to do to create a new, to populate other CIs in the CMDB. So this would not appear to error anywhere, because we haven't tried to populate the files, the CI, the class that we said we were going to populate. It would just go, I don't know where to push it. So it's always worth double checking when it doesn't appear to push data to the CMDB. Also, have you been given the right string values? Have you been given CC 3%, or is it lowercase in the CMDB? Confirming those values, and an example would be that on the forms in the CMDB, they can be pretty names, they're just labels, but in the backend tables, they may be different. So it's always worth confirming with your CMDB person, are they the names or the labels? Because those attributes do not exist in my CMDB today. I'm trying to map to something that I haven't declared. This pattern shouldn't work, but we want it to work, and the fix would be match that to that, or that to that, whichever way around. Confirm these two attributes are created in the CMDB, and that will then create data. It will transform the data. It will prepare the data. When it tries to push the data, it will not go across. I have gone through the three types. I'm going to stop there and suggest to Sam that we skip to, or move on to Q&A. Does that sound about fair, Sam?
Yeah, we have quite a few questions actually. Everyone's been very patient in the audience.
I do apologize, everyone. It can be a very complex conversation, and trying to bring forward some different examples. We could spend all day on each and every example. So I'm going to stop talking, take off camera and stop sharing, and then yes, we can have a conversation.
We will obviously also be sharing some of the links that we do have in a couple of slides. We'll be sharing out the slide where the main thing is to get to the questions. So I'm just getting everyone unmuted. And why I do that, let me start with the first question, Matt. So there's a question come, does the common data model cover telco domains like radio access networks? If not, what is the best practice to expand the CDM?
Oh, very good question. I am not a CMDB person, so I would look to get the confirmation of what I'm about to say from your CMDB. I believe there are base classes for telco, but I'm not aware of a full telco data model in the CMDB out of the box. But it is an area that we are moving towards. We're seeing an awful lot of customers wanting to bring their telco into the the ITSM world, and it's that mapping of data. The telco view of the world of data is different to IT's view of the data. We are looking to do that. That is an area of interest for certainly on the CMDB side, and discovery in getting it, and then figuring out, being told by the CMDB, put your data here, please.
Thank you. It was asked by someone that I don't know who their name is. They've come anonymous. So we'll move to the next question. So another one was, is the template a collection of a pattern?
It's a straight pattern, so you can download it as a piece of tipple. You could bulk load them back up as a zip file. If you have multiple patterns, you can zip them, as I did. And then when you have to edit one because you made a mistake, you can upload them individually. But just like normal patterns, they can be collections. You could have multiple sync mappings in one piece of tipple. You could have multiple pieces of tipple in a zip file. You can group them just as you do with standard tipple.
Thank you, Matt. Next question was from Jose. I can see Jose is still on, so Jose, feel free to come off mute. His question was, is there a type of mapping with priority? Could you indicate how it differs from normal mapping and what are the implications?
Oh, that's a really good question. I'm actually going to defer to the documentation and say, yes, there is. I have seen it, and I believe I've used it myself in time, but I can never remember its actual purpose. So I'm going to suggest we take that away and get you a proper answer. Yes, it does exist. Yes, I have used it. It's the implications that I want to square away on the response.
Okay, I've just put a note into there, so Jose will come back to you.
Thank you, Jose. I love those questions that make me have to go and learn something.
Great. Manny's asked a question. If we need to extend the mapping, for example, in a table and enumeration, add entry like appliance, how can this be used in Discovery if the same is updated in the primary capability in CMDB?
If it's an additional primary capability, I would update those enumeration tables, and you can import those tables in the from section. But do you want to ingest different bits of table to then have an extension pattern that the body is really short, but you're doing loads of weird and wonderful imports? I'd probably use an override in that example. And that's what I did with the processor example, where we found the system type, and the system type was using a table. And I created a new entry in my CMDB, entry 11, for testing, just a really random string, not a processor. But I then used the override function of a type of pattern to bring in the entire processor pattern, update my lookup table in enumeration table, and then edited the body in itself to push that string from the table. So I would use an override pattern personally.
So Matt, I think just on top of that one, right? Should we use the override and add the one more entry of the capability in the enumeration and the table, or should we just go and extend just by adding one entry or two or three entries, which we need to incorporate in our primary capability? Which is the best practice, right? Should we go and override in the 56 entry? We can go and incorporate the 57, 58, 59 over there. Or just three entries, create one extension pattern, right? Just import the existing one and then put our logic over there.
I like that example. You could override the primary capability value with an extension pattern. You do a double import to use an extension pattern, you would import the enumeration table. You would also import the host computer system, for example, and then you would set your primary capability in the extension to override what the TKU has set. And then you would have an isolated piece of code with just your updated table and your shortlist of override piece.
But is it going to impact anything? Because as you said earlier, right, every alternate month or every month TKU is getting updated, right? And the CTI I have seen in the month of July, there was a comment keep coming, right? The CTI, you are going to modify or change the CTI values, or BMC is going to change the mapping, right, in down the line 6 to 12 months, right? So if we do this kind of modification, right, how we will ensure in future through the roadmap, if somebody has changed, or through the TKU if it is coming up, okay, because we don't know, right, as on today, what would be the CTI. So based on our knowledge, or our application custodian, whomsoever is requesting, right, we are just modifying those CTI information and the primary capability, right? So in future, if those are getting extended by BMC itself, how it is going to be impacted? Because if you go and upload, okay, our pattern, our custom sync is already there, right? So how we'll get to know, how we are going to leverage the BMC, right? The BMC out of the box TKU, right? Which has all these things already included in future.
Absolutely, and that will be a consideration when those monthly TKU emails come out, to review them and confirm that they work with any customizations you have. So I believe, and I'm really stretching my knowledge here, in the CMDB, there used to be a recommendation that when you're doing customizations, you don't follow the next number in the list. And so where you're creating custom entries for lists, you use a high value number to avoid updates to the out of the box. So absolutely, as you suggest, if we create 58 today in the product, then that's going to push to a value which in the CMDB is defined as something completely different, not going to match. It's going to fail the CMDB sync. So it is always worth reviewing those patterns, making sure that they adhere to your definitions. And in the example of using an extension pattern, it may be that you import the out of the box pattern, which has the new 57 and 58, but you actually change those numbers. It's the same consideration when you update the CMDB. When you update the CMDB, that's also going to try and bring in these new options to stuff you already have, to numbers you have already consumed. So it's managing those upgrades is what I would suggest. And yes, it does have a consideration that if you have created custom entries using the next order in the series, then that doesn't allow for any futures of the product out of the box. And so the impact is exactly as you're suggesting. I'm going to try and push to 58. 58 doesn't match the strings that I have in my list, or it's going to consume the custom values, which are not going to match to what Discovery thinks it's trying to send over.
So what you are suggesting, we should use some random values, right? The big numbers, right? Which we are not, because I can see this, the 56, the CDM is since era, right? Almost decades, right? The same value.
And I definitely would confirm that with someone who is more experienced with the CMDB, but definitely I would confirm what I've just said about using higher values for custom entries. It may not apply to this scenario, and I may be using it out of context. So it's definitely worth checking on that. But ultimately, if we have custom values and you're using those next order in the series, you cannot upgrade your CMDB generically from the point of the last version that we may have that you have. Any additions are not available for even upgrading the CMDB for Discovery to then consume.
So Matt, I think as per our, as you have seen, right, in our enumeration table, right, the 56 entries are there. So it means the new entry which we are going to, the custom entry which we are going to create in the CMDB, right, for the primary capability, ideally it should be 57, but as per our suggestion, suppose we are going to use 200 example. So in our extension table, should I refer the same 200, or any numbers I can just use it over there?
In your reference table, you want to use the same value as it is. So when you're extending those lists, you have the strings and you have the IDs, and you want to match
Correct.
those two. Make sure they're matched in your table in your sync pattern. So where I set testing 11, I could have set in my CMDB testing is 200. And I should have done in this example to support this conversation. Set the value to 200. That's what I put into my enumeration table. Testing 200.
Okay, got it. Okay, thanks, Matt. Thank you. I think I'll try.
Manny, I definitely recommend having a chat with someone who is a full ITSM person. But I
Sure.
definitely would confirm that. And I'd be interested to hear feedback as well on that question.
Manny, if you want to sort of drop all your questions to me post-event, I work with the CMDB team, and in fact, I have got someone from the CMDB team running a webinar in December, but I'll see what the context is, because some of these questions we might be able to filter in a bit like with Matt today and working with Michael, who brought a lot of these questions for this particular session. There may be some content that I can get for you. So if you want to maybe drop me a message, or I'll reach out to you after. Okay.
Sure, Samantha, you can.
Yeah, no worries. Okay, so we'll just get, I'm conscious of time because we have run over, but I'd like to get to everyone's questions. Hopefully they're still here, Matt, and we can obviously follow up on these after. So next question was from Kieran. Kieran was asking how to do the mappings to custom attributes. Kieran, if you're still on, I think you are, feel free to come off mute as well. I don't know if you can hear us, but Matt, a question was how to do mappings.
Yeah, hi. So we have a requirement where the customer is asking to add. So we have introduced few new custom attributes actually in CMDB, and the IADDM is actually scanning those. So we just need to map to the new custom attributes which we have introduced in CMDB.
Okay. Yep. That would be, sounds like an extension pattern off the bat. Are they on computer system, on host nodes, or are they on child classes?
It's on computer system host.
Then just as we looked at the template, that sounds like a perfect example of grab the template, download it, edit the body to say source and destination, should be good to go.
Sure, maybe I'll try and I'll let you know if something.
Absolutely.
Sure.
Definitely, this has been a hot topic on the communities over the years, and I think there's a great opportunity to build some conversation based on experiences. So as we are all trying these things, doing these things, I think post them to I ask everyone post to the communities if it's not sensitive, so that we can all benefit from each other's experiences. I may well look to do a blog to just post up the tipple that I've been showing today, that will hopefully help out someone somewhere.
Can you get this recording?
Yes, we're going to be sending out everything today. We'll also, Matt, if you did want to post a blog and want to put a Word doc, I can add that as a blog post. So we'll coordinate. But yes, the recording, the slides, everything that we've shared today, including the Q&A, we will follow up and send that out as a blog post. Okay.
Sure. Thanks.
Great. Thank you, Kieran. So Eric, I see you're still on. Eric's question was, would it be possible to customize sync behavior for absent nodes?
I would probably just suggest an if statement. So so for example, with the file system code, we could add in an if statement, or it's actually in the mapping that's handling missing data. So we're only traversing to host nodes with the file system mounts and only trying to process existing data. If we are assuming that an attribute is populated, then again, we would look to set either a default value or a blank value, and then, as with normal tipple, set variable equals none, and then if variable on node, then set the variable to the value. And then when you're pushing over to the CMDB, if you've got any mappings, you define the variable in the code, in the body, which means we have a non-value to put into a field in the CMDB. So I think there are, is it name and short description are the sort of standard required fields. Everything else is generally optional. So if we don't have memory, if we don't have serial number, you could set a variable in the body that says serial equals none, set serial number to serial number, and if it's populated, great. If it's not, then it will go across as a blank entry. I think that answers that question. Please shout if I haven't.
Eric, can you hear us? I can see that you're off mute, but sometimes people join that's not via the client, so they can't always speak to us with audio. Can you hear us? I don't know if you're talking, but we definitely can't. So if you want to reply back and say whether that's answered your question, that would be great. Conscious of time, I'm going to take one last question from Jan, and then everyone that has asked us questions, and apologies.
Could I suggest we take the last question, actually? Because Jan,
yeah,
I will absolutely respond to that. And the PowerPoint, there are links to the documentation that go into much more technical detail than I've given today. So we will look at the key expressions question and get an answer on that. But there's a really interesting one at the end, which is talking about weighted values. There is an attribute on cluster class. I'm going to talk about it in the context of cluster class, not BA, not application and business service. But it applies to any class that has that field. Impact computation model. By default, we send to standard. We send the string standard, but there are 3 values available, and I can never remember the third one. It's standard, weighted cluster, and something else. I actually have another pattern that we didn't get to today, and we'll post it. Looking at cluster and setting that value to weighted cluster, which means that all of its child nodes, it should in theory then do a division. How many children do I have? Set the value, set the weighting to a division of the child count. So absolutely you can do that, and we will we're actually looking to see if that's an opportunity to bring into the standard content.